Good morning, student. In the last lecture, we have studied how to draw the ray diagrams to get an image by the convex lens. Now today we are going to see about the image form when the rays of light or object is placed in front of the concave lens, right? So there are only two cases. First case, when object is at infinity. Okay, this is the first case for the concave lens, right? So say that this is our principal axis, then lens which we are going to take is a concave lens, right? Like this, say concave lens. This is the principal section of the lens, right? And the object is at infinity. As I told you in the last lecture, that if the object is at infinity, then the rays reflected rays from the object get incident on the lens parallel to the principal axis, say. So assume that the reflected rays from the object incident on this concave lens parallel to the principal axis. Okay, as we know, here is the f2, your optical center, here f1. Now, what happened over here in this case? In this case, you find that the ray of light which is parallelly incident on the concave lens, after refraction, it diverges the ray of light and seems to diverge from the optical center. So here we are getting like this, the refracted rays. Okay. Now, when we back produce this refracted ray, then it meets into the focus f2, right? So, what is the nature of the image form? So, nature is first, it is a virtual one. Image form is virtual. Second thing, it is upright. Okay. Third one, it is at the focus, okay. Fourth one, on the same side of object, okay, on the same side of object, not in the opposite side of the object. In case of the convex lens, we find that the image form is on the other side, opposite side of the object, right? But in this case, we find on the same side. Okay. Now, one more thing is that what are the applications? So, application of this type of arrangement of the lens, concave lens, is that it is used to see the far object or distance object by telescope, right? So, here we can say this is used in Galilean telescope, okay. So which is used, this telescope is used to see the objects which are far from the earth, okay. Next is when the object is at any finite distance, okay. When the object is at finite distance means over here we are going to talk about all cases which we are seeing in case of the convex lens, right? So take object at anywhere, take a principal axis, and then the lens over here, which is a concave one, okay, concave lens. This is the principal axis, intersection of principal axis and the principal section is optical center. Here the focus f2, here say f1 is the focus, here we can say 2f2, and here I say it has to f1. Now, assume that the object is at anywhere, say it is at beyond 2f2. You can take at 2f2, you can take between 2f2, f2, you can take on f2, you can take f2 and optical center. At anywhere it is, okay, the same diagram is and same the nature of the object is, okay, whatever the difference that I tell you later, okay. Now So at least 2 rays we require to draw a ray diagram as well as to get the image formed by the lens. So one of the ray which is parallel to the principal axis incident on the concave lens, after refraction it seems to pass through the focus. So this is one of the ray. Another, if the ray of light passing from the optical center, then it is undeviated after refraction. It is undeviated after the refraction by the 3 rules of the rays, right? Now here you are getting this intersection of this refracted ray. If I back produce, so same over here, right? They meet here at the point say A dash. Okay, A, B is the image. So here, object. I say B dash over here, that point of intersection of the 2 refracted rays from the rays. Now here you find this image between the optical center and the focus. I can say it as the image formed in the focal length. Okay, so anywhere is the objective, then you find that the image is formed between optical center and the focus only. Okay, in all the cases, only at the infinity when the image form is at focus, but in all the other case, if the object is at beyond the 2f2, it is on the 2f2, it is between f2 and 2f2, it is on the f2 when it is between the optical center and the f2. In all the cases, the image form in between focal length, or we can say optical center and the focus. Okay, so this is the common case, okay, for all the positions of the object. So only one case we are going to study over here. Now let's talk about the nature. What is the nature of the image form? So nature of the image form is, first is, it is virtual. Okay, so it is shown by the dotted line. Don't show it by solid line. If real, then show by solid line. But if it is not, then show by dotted line, as I shown here in the diagram. Second thing, it is upright. Upright, you can say object is at plus y. Image form is also at a plus y. So upright, I can say. Third thing is that it is highly diminished. Highly diminished. Diminished means it is smaller than the size of the object. You can see image is smaller than the size of object. Fourth, position, where it is image formed in between optical center and focus. Okay, means within the focal length. Okay, we can say within the focal length. Okay, and fifth, application. What about application? Okay, this type of action of this concave lens is used to correct the short-sightedness, the person who have a problem of short-sightedness, right? So it is used in spectacle. Spectacles, short-sightedness, I can write here, short-sightedness. Okay, so this is the application. So what happened if the object come near to the lens? What about the image? Image also shifted toward the lens. This is first thing. Second thing, what about the size of the image? As the object moves toward the lens, then the size of the object goes on increasing, but always it is diminished. वो डिमिनिश ही रहेगा, यानी ऑब्जेक्ट के साइज से बड़ा कभी नहीं होगा. Okay, so it is lesser than the size of the object. Image size is lesser than the size of object, so we can say it is diminish only at all cases, right? Only we can see over here that the size of the object image form is increased when the lens comes near, object comes near the lens. Okay, so this is the second action of this concave lens. Okay, so this is all about the concave and the convex. Both you keep in mind. Okay, now we are going to study the next topic. Let's see that. Next topic is about the sign conventions and the lens formula. Okay, this topic is omitted by ICSE for this year, okay, due to this pandemic situation. Now this exercise is dropped from the syllabus, so don't worry about it. Now we are going to study about the next exercise, which is nothing but about the magnifying glass and its application of the lenses. Okay, magnifying glass and application of the lenses. Magnifying glass. First thing about the magnifying glass. Okay. To see the object distinctly, we prefer the places which is near to our eye as possible, right? Means least distinct vision, distance of least distinct vision, right? To see any object clearly, what we are doing, we are keeping that object at such a distance that we can see the object clearly, and that is known as least distance of clear vision, right? And that is nothing but a 25 centimeter. If we keep the book near to our eye, it looks a blur one, which is between or 0 to 25 centimeter. If then we can see the object blur. Okay, you can take an example of the while reading the book. If you keep the book near to the eye, then you find that it looks blur. And if we keep it away from the 25 centimeter, more than 25 centimeter, thereafter we can see that the objects are not clearly seen to us. Means to see the tiny objects clearly, it should be at least at a 25 centimeter from our eye, then and only then the image form on the retina is clear and we can see the clear picture of the image, right? So second thing, when very tiny objects which we can't see with the naked eye, then what we can do? We can use a microscope, right? And that is nothing but a magnifying microscope. We can say magnifying glass. You can see that the doctors which are observing the skin diseases, they have to use such type of magnifying glass and they can see easily the distinct, these tiny objects clearly, right? So we are going to study about the function of this magnifying glass. This magnifying glass is constructed with the convex lens and which is fitted into the say plastic case or steel case or any metal case, right? And we know the function of this magnifying glass, okay? But this magnifying glass acts as a 6 case of convex lens. Keep in mind, 6 case of convex lens means when the object is in between focal length, then the image form is virtual, upright, magnified on the same side of the object, okay? And this 6 case diagram is same for the magnifying glass. Let's start with this, okay? Now when the object is placed below the magnifying glass, okay, then what happens? Let's see, here the principal axis, then the convex lens, optical center, principal axis, and this say focal length f1, here focal length f2, here 2f2, and here say 2f1, and the object is over here between the optical center and the focus, or I can say between the focal length. One of the ray which is parallel to the principal axis after refraction passing through the focus. Actually passing through the focus because it is a convex lens. So convex lens action. Okay. Now one of the ray which is passing through the optical center after refraction, it is undeviated. Okay. And as I back produce this ray, then what I find? As I back produce this ray, then it meet here say somewhere, and the object, the image form is enlarged one as well as it is beyond the two objects. Say AB is our object, then we are getting A dash, B dash as the image of the object. We can see that the image formed over here due to the convex lens is magnified one. Similarly, it is virtual one. It is on the same side of the glass. Similarly, it is upright one, right? It is upright one. And this nature of this convex lens is used to magnify the tiny objects, to get a magnified image of a tiny objects, right? So in the microscope as well as in the magnifying glass, this type of action of the convex lens is used. Okay. Now last topic which we are going to study about is application of the lenses. Lenses are used in a large number of optical instruments. First, the objective lens of a telescope, camera, slide projector we are seeing in case of the convex lens. Okay. Next, our eye lenses is also a convex lens. Eye lens form inverted image of the object on the retina. Third application, when our eyesight weakens, we use the spectacle having either the convex or a convex lens. So person who is suffering from the long sightedness, okay, which is known as hypermetropia, who cannot see the near object distinctly, wear the spectacle having the convex lens. Hypermetropia, convex lens. Then myopic persons are there. Though those are myopic one, those can't see the object which are at a far distance. Okay, so those can wear the spect of concave lens. Some people have a both problem, short-sightedness as well as a long-sightedness. They use the either separate spectacle for seeing the near as well as the far object, or they use a bifocal lens. Okay, bifocal lens means double focal length उनको रहेगी. Okay, the magnifying glass is a convex lens of short focal length fitted in a steel frame provided with the handle, which is also one of the use. Next is in the collimeter of the spectrometer that we had studied in the convex lens, 6 cases which we studied. In that I told you a lot of applications. Convex lens is used for obtaining a parallel beam of light in the spectrometer, where the collimeter is used, right? A concave lens is used as an objective lens in the Galilean telescope, just I told you, and single convex lens usually form a color or a blur image due to chromatic aberration. So therefore a combination of concave lens with a convex lens is to overcome this defect of blurring. Okay, so these are the uses of the lenses. So these uses, then magnifying glass in this exercise is important. Next is experimental verification or determination of the focal length of the given convex lens or the concave lens. That topic is practical one, so it is not in the theoretical part, so don't worry about it. So this way the chapter is over. Okay, we will see next chapter in the next session. Thank you.